I want to start by thanking the Schumann Center and you, Xavier, and the FSR Climate Group for inviting me to come here and spend a few months and work on some research. You've been very hospitable, and it's a real pleasure to be here. So what I'm going to talk about today is sort of a broad agenda of research themes and ideas that I've been working on for a while now, but trying to bring some ideas together. It might be a little atypical for a applied economics seminar in that there's going to be a fairly broad approach, a big picture approach. The idea being that this big picture is, I think, leads to some judgments and some observations, some conjectures that then I think lead to some more specific, more focused areas of research that I am working on or that others may be interested in working on. So the title, The Challenge of Climate Policy, No Time for Wishful Thinking, I think the sense of that title will become clear as I go forward. There are, I guess, these three main themes and ideas that I'm going to link and develop. The first is that there's an urgency to addressing climate change, to stabilizing greenhouse gas concentrations in the atmosphere. That's something that a number of people have been saying for quite a few years now, including a recent themed issue of, I think it was Environmental Resource Economics, that Thomas Sterner has sort of an overview piece and begins with some statements about how this notion of urgency, that it's 5 minutes till midnight in terms of needing to do something to address climate change. I think that's an important point, both in terms of timing and the policy process that has been ongoing for quite some time now. The second theme turns to the literature on what we know or what we've observed, what we think we know about international environmental agreements, treaties, and from economics, from political science. There's quite a large literature and many case studies and analysis suggesting that it's very difficult, that we don't have a lot of reason to be optimistic that international environmental agreements will result in countries doing things beyond very sort of minimal steps, things that will involve serious costs or consequences to their own country. We don't find many examples, and we don't find support in the literature for that. So that leads to the third part of what I'm going to talk about, and that is overcoming these obstacles will require additional novel approaches. And so as at a general level, I'm saying, look, given what I sort of have laid out and think is supported by the evidence, are there other levers? Are there other tools? Are there things that one can point to that might alter the calculus, alter the likelihood of success along the lines of abatement? So that's an overview of where I'm going to go with this talk. I'm going to start with a simple model, not a very detailed model, but one that I think provides some framework, some grounding for some of the observations I'm going to make, and I'll come back to it a couple of times. But also, there will be a place where we'll see that the climate problem is one that doesn't fit this model very well. So this is from a 1981 paper by Richard Zeckhauser, Preferred Policies When There is a Concern for Probability of Adoption. And I think that's a key element of what I'm focusing on here, is as we think about what one should or can promote to address climate issues, keep in mind not just efficiency, not just maximizing social welfare as we measure it or try to measure it in economics, but take into account the probability of adoption. A policy that has a low probability of adoption, even though it's the optimal policy in principle, is not going to be as appealing. And Zeckhauser says a theory of effective policy choice is developed that recognizes that the probability that a policy is adopted depends on who gains from it, who loses, and by how much, because those are the dimensions in his framing of the problem that give an indication as to whether it's going to pass in terms of legislation being adopted or government support. So there are sort of three parts to this model and what Zeckhauser does with it. He's looking at environmental policy, domestic policy within the United States from quite a long time ago, but some important environmental legislation was passed then. Standard benefit cost analysis does not incorporate into it the likelihood of success of different options. We tend to rank them in terms of the benefit cost ratio or net benefits. Second, the best option under benefit cost analysis may have zero chance of adoption, best in the sense of that net social benefit. And so third, then, are there ways to alter the probability of success? And that's what Zeckhauser does. So I'm going to give you a little bit of a sense of what this model is. It is really quite simple, so I won't spend a lot of time on it. Let Bj be a vector of individual benefits, I across individuals for a policy j. So we have the Bj as a function of the benefits to the individuals of that policy, where some B sub ij's may be negative and where we assume that these are to be certainty equivalents, that we've taken account of uncertainty and risk in some way. So that the total benefit of the policy is T sub j, which is just the sum of the individual benefits. That's sort of a standard way of thinking about benefit cost analysis. A naive maximizer would choose the policy that maximizes that capital TJ, the total net benefits for a given policy. Or if we wanted to apply differential weights to individuals where some group might want to be given more weight for equity reasons or entitlement reasons, we could do that. Okay. But if the probability, capital PJ, of success or passage is uncertain, we can consider that probability as the P of B, where the net benefit is weighted by the probability of success in some way, passing legislation or successful implementation, or in the case of climate change, the success of, say, a global agreement to reduce carbon emissions. We assume that the probability of success increases with a marginal change in the benefit to all individuals. We assume that's greater than or equal to 0. So we have a strategic maximizing behavior, maximize expected net benefits, R sub j, where we've defined R sub j to be that probability of adoption multiplied by the total benefits of that particular option j. So we could have several alternative policies. They may differ in terms of net benefits, and they may differ in terms of the probability of success. And so we're going to think about weighting them in terms of, expected success of policy being adoption would be a way to look at it. And assume that this is the way Zeckhauser approaches it as well. Assume that this is a one-time only proposal and that if it is defeated, the status quo S will persist. Okay. These graphs are from the Zeckhauser article, and basically he's just showing you have a possibility frontier in a simple world with two individuals, the one on the left here. You have a status quo S. D is the optimum. That's where the possibility frontier is tangent to a line of a slope -1. So you've maximized the sum of the benefits from the two individuals. But if you have a lower probability of success of it actually being adoption, then maybe the best policy will be over here where you have a higher probability of success, but maybe a little bit lower net benefit. Here's a case where strategic maximization with no Pareto improvement, the status quo is on the possibility frontier, and you may not want to move very far from that because to do so would make individual one worse off if you move in that direction. So just giving some flavor of the idea of how the model can be thought of in terms of trade-offs between net benefits and the probability of success. I found this particular paper and its approach appealing and useful for reasons of setting up the idea of trading off net benefits, which we always do in economics, and recognizing that some approaches may have a lower chance of actually being successful, being implemented. If it's not going to be implemented, then its net benefit is going to be zero. If it's not going to get there. Okay, I'm going to come back to the model and some of the conclusions and the way Zeckhauser interprets what one can do in his context to improve the odds of success, to make a policy more likely to be adopted. But I'm going to turn now for just a couple of minutes. I'm not going to go into the science behind climate change. I think people here are familiar with it. Just draw attention to the IPCC summary for policymakers, the idea that there's been a lot of analysis of different paths that could be achieved, different ways we might try to begin implementing policies that would reduce emissions and thereby stabilize greenhouse gas concentrations at low levels, medium, or high levels, depending on how aggressive and what kinds of technologies are available and adopted over the next few decades, this going to the year 2100. I wanted to show something like this at the outset because this is probably a graph that everyone in the room is familiar with. But a lot of climate scientists have also looked at issues of the persistence over time of emissions and concentrations, even if you halted, even if in the year 2100, after some path between now and the year 2100, if you stopped carbon emissions, if you went to zero, what would happen after that? And so here is a figure from an article in the Proceedings of the National Academy of Sciences, Solomon and co-authors, Susan Solomon and co-authors, where in a climate model, the graph is a little smaller than the graph is a little smaller, but the idea is these are some experiments that she does. In the model, she simulates certain paths of increased emissions, and then at different levels, the emissions stop. When the concentrations get, in the first case, to 450 parts per million, emissions go to zero thereafter. In another simulation, 550, 650, 750, 850, and I guess 1200. But even with zero emissions after that, you see what happens to the concentrations. They very gradually are lowered over the course of several hundred years. This goes to the year 3000. Surface warming continues, and you don't, even after carbon emissions go to zero, the warming in some cases even goes a little higher, and then you see a very slight decrease over a few hundred years. And then thermal expansion of the oceans. A lot of this slow response is apparently due to the interactions between the air and the oceans and parts of the climate science I don't understand. But my reason for including this is to reinforce the idea of irreversible damages, that if climate policy, instead of really reducing emissions so that concentrations can be stabilized at 550 or 650, if we go up to 750, 850 and beyond, those changes are essentially irreversible. If a few hundred years we can more or less consider to be an irreversible change. And that's where, according to the scientists that I read, the risk of catastrophic change is greatest. Okay, so with that in mind, urgent need, irreversible damages, I want to turn to this literature on international environmental agreements, which suggests, and there's a lot of literature there, without special features, the outcome for global public goods will be non-cooperative tragedy of the commons. Scott Barrett is perhaps the name best known for some of this literature looking at international agreements in general and in particular environmental agreements. He concludes international agreements can do little to improve on the non-cooperative outcome when the number of countries that share the resource is large, and there's theoretical results in game theory that come to that. There's empirical evidence. There's quite a lot, and it's one of the areas that there's a fairly strong consensus, it seems to me, in that literature. The second paper here also reinforces that asymmetries in international environmental agreements. Considers self-enforcing international agreements. This confirms a persistent result in this literature that large, stable coalitions usually go hand in hand with low gains of cooperation. So almost token gestures in terms of the agreements, or one way it's been described is international agreements of this kind end up having countries do things that they were going to do anyway, with or without the agreement. I want to include some discussion of a related literature, but one that is maybe not as often included, and that's the work of Elinor Ostrom, who won the Nobel Prize in Economics, a political scientist, a lifelong student of what goes on in terms of management of common pool resources. And her conclusions are very similar. She finds successes. If we think of the international arena as one example of common pool resources and countries that are trying to come to some cooperative solution or common agreement, very similar to the studies, the many studies that Elinor Ostrom did over the course of her career on villages and pastoralists and fishers in developing countries. And she concludes that when the question, when will users of a resource invest time and energy to avert a tragedy of the commons? When expected benefits of managing a resource exceed the perceived costs of investing in better rules and norms for most users and their leaders, the probability of users self-organizing is high. That's sort of consistent with the Zeckhauser model. It's consistent, I think, with the international agreement, international environmental treaties or agreements literature that I mentioned. She concludes self-organizing to sustain a resource costs time and effort, can result in a loss of short-term economic gain. These costs, as well as the fear that some users will cheat on rules related to when, where, and how to use a resource, can lead users to avoid costly changes in current practices. So again, I'm going to refer back to the work of Elinor Ostrom as I talk a little bit more about climate change in particular, but I think these couple of slides are meant in a fairly broad brush way to acknowledge some literature that I think is important to some of the conjectures about likelihood of success in this arena. What I want to do next is use an example. There are a number of examples we could use of other examples, historical examples, where efforts to find agreement internationally have been tried and have maybe had some success, but perhaps over a long period of time. I think there are some overlaps and similarities with the GATT efforts to reduce barriers to trade after World War II. This is a process that began in 1947. Countries realized there had been kind of trade wars that had raised tariffs around the world. They were all very high. Countries got together in a way that's not so dissimilar from what we've been seeing with the UN framework for climate policy. Beginning in 1947, and you can see from the chart on the left that with rounds of negotiations over a 50-year period, more countries participated over time. This is the middle graph shows the participation trend. Tariff cuts increased. These were cumulative cuts in tariff rates, and the resulting increase, their GDP growth and merchandise trades is at least partly due to this reduction in the tariffs that were obstructions to trade. Now, one difference, I think, is that some of these benefits to GATT, to reducing tariffs, were fairly immediate. Countries reduced their tariffs. They probably saw, in a fairly short period of time, improvements, increases in trade and benefits to their economy. Let me compare that to what we've seen so far with efforts to implement policies to reduce carbon emissions. This is monitored by the World Bank, one of the places where this kind of these policies are monitored. This is focused on carbon taxes and cap and trade schemes that do the same, do similar. This graph shows the trend since 1990. The colors indicate the countries. There are the countries starting with Finland and Poland and Sweden, and you see an increase in the number of countries, and you see an increase in the fraction of carbon emissions that are covered by these carbon taxes or these cap and trades. None of them are 100% covering all the carbon emissions in a country, but some fraction of them. I think it's the red. If this is red, that's when the representing the EU ETS is included in here. And you can see that in terms of carbon emissions, global carbon emissions, the scale that goes up to, 10%. And then going forward, there are a couple in here that are speculative. So this graph is interesting in that it shows the sequence of countries, additional countries adding policies that, price-based policies. Here you have information on the actual tax rate. So we had the countries, the number of countries. We could look at sort of the population covered. We could look at the share of the economy that's covered by these programs. And here we can see that the tax rates, there are a few that are high, but there are many that are quite low. And what I wanted to look at to get a sense of progress, this has been 25 years since the first one started. What does this show us in terms of a progress toward global coverage of carbon emissions policies that would reduce carbon emissions along a path consistent with some of the paths that have been described as necessary to stabilize the climate over the next 80 years, say? Well, to do that, we need to look at all the countries that are involved, the portion of their economy that's covered, and the tax rate, so that we have one way we could measure it is sort of a weighted average carbon tax for the whole globe. So put all the countries in. If they don't have a policy, they get a zero tax. If they have $120, they get a high tax. But let's do a weighted average for the global carbon emissions. What's the weighted average carbon tax? And this is a rough calculation. It's a bit complicated, as I'm sure some of you know, to try to come up with a number for the tax rate and the part of the economy that's covered by that rate, and find equivalence between carbon taxes and cap and trade especially in programs where there's phase 1 and phase 2, and the country has both a carbon tax and is part of the EU ETS. But that global average is quite low. It's less than $1. And let me compare that now. That's all that previous data converted to a global average carbon tax. Let's compare it to those projections that have been made. There are many places one could turn to come up with a projection of a carbon program that would be necessary to stabilize climate based on some criteria of optimality or maybe risk aversion. Here are some lines that I've put in the graph. The three that are flatter than the other two are from U.S. Interagency Working Group. One for assuming a discount rate, an optimal path for a discount rate of 3%, one for an optimal discount rate of 2.5%, and then the darkest of those three is kind of a risk-averse approach where you're assuming 95th percentile on your estimates of the range of possible damages that would occur. The other two, the steeper ones, are from a paper by Dietz and Stern in Economic Journal. It just came out last year. And they include a range of probabilistic outcomes and potential climate damages and have kind of a low-end path and a high-end path. It's hard to see the line from the actual implemented average global carbon tax compared to these. I'm going to scale it down so the upper end of the tax scale is $100 instead of $250, and you can still just barely see that line. So compared to what some analysts are saying is the path we need to be on to stabilize climate in a range that's considered to be optimal by some of these analysts, you can't really say that we've made any progress based on this average carbon tax rate up through the year 2015. So with that in mind, let me go back to the model. Zeckhauser says that one way we can try to increase the probability of a policy is maybe we can shift the benefits around. If we can shift some of the benefits, it's essentially implementing what would otherwise be a Kaldor-Hicks compensation criterion, turn a potential Pareto improvement, move it toward a Pareto improvement, make it so that a larger share of the interests on whom you depend for passing legislation, have it so that a larger group of them have a positive net benefit rather than a small. Maybe take some benefits away from someone who had very high benefits to someone else and give them to someone else who had negative benefits. And so, in a two-individual world where benefits can be transferred, assuming that the benefit the marginal benefit the change in the probability is higher for individual 1 than for individual 2, even though there's a cost of transferring those benefits through some mechanism, optimality would be achieved when that expression is equated. You've moved the benefits around to the point where you've maximized the probability of success. Okay. The left-hand side represents the gain in expected net benefits due to an increase in probability. The right-hand side gives the loss due to the lower level of total benefits. So you're essentially trading off probabilities and net benefits by shifting things around in some way. So, well, how can you do that? Zeckhauser says, well, here are some examples. Coupling with mechanisms used in the U.S. environmental policies to spread costs and benefits. Essentially, take benefits away from people who would support the policy at a lower level of benefits and shift those benefits over to other individuals that wouldn't support the policy unless their benefit level was brought up. Example A, coupling with additional provisions or legislation. So link legislation that have maybe overlapping interest groups. More people are happy with the two policies together than they would be with one or the other independently. I think in political science this is called log rolling, at least in the US. compensating benefits, indemnities. Type B, delayed or phased implementation. You delay something being implemented. Some people have a high discount rate. They're going to be less, they're going to object to it less if something they object to comes later on. So stepped introductions of fees or implementation, flexible deadlines. The third category, manipulation of uncertainty, essentially mislead people. Introduce a policy in a way that some people are going to think their benefits are going to be larger or think costs are going to be lower, and then later, or that's one interpretation. Clouding the identity of the losers, leaving form of impositions in doubt. This is exactly what was done with Obamacare, with the health care in the United States, and there was some controversy afterwards. President Obama said, if you want to keep your health care under Obamacare, you'll be able to, if you like your current health plan, you'll be able to keep it. And that wasn't true, and it came out after the legislation passed that in fact it wasn't true. Some people, their plans would go away, and they knew that, but they manipulated the uncertainty. But what if we have a case where everyone's net benefit is negative? What if we have a case where it's a non-Pareto improving situation and where most individuals are like individual 1, that going from S to D or going from S to D to, well, in this case, individual 1 would be made a little bit worse off. Individual 2 would be made much better off. But what if we're in a case where we're starting at S prime? That is where everyone is better off in an immediate sense than if you go to what is, in a sense, the utility frontier, because that frontier takes into account climate damages that are in the future and not right now, or maybe they're benefits to future generations. They're highly uncertain, but individuals have a very small the extent to which individuals will take into account in their own calculus about supporting legislation, many would not put a lot of weight on very uncertain benefits potentially to future generations. So the idea here is to point out that climate is even unusual in a number of ways compared to sort of the Zeckhauser's framework for thinking about how we can manipulate the net benefits to increase the odds, because the net benefits, certainly in an immediate sense, at most discount rates, are going to be negative for most individuals and for most countries, unless you put a lot of weight on future generations or some ethical commitment to stabilizing climate policy, which some of us do, but in the real world, it does seem like a challenge to figure out how we're going to take this framework and think about how to alter those payoffs. One of the reasons being that a lot of those payoffs are non-tangible. They're not dollars that you can transfer over from one individual 1 to individual 2. If I'm committed to protecting the climate, there's no way you can sort of make my benefit of that lower and somehow transfer that to another person. It's an intangible, it's a non-market benefit. Let me come back to Ostrom's work. This is in an article in 2009 in Science. I think this is after she won the Nobel Prize, or about the same time. If you're familiar with her work, you're familiar with her lists. She makes lots of lists. If you're not familiar with her work, I encourage you to read some of it. It's really, I find it just fascinating and a real insight into institutions, how they're created, how they evolve, and how they can work in these kinds of contexts. So she comes up with this list: factors affecting the likelihood of users engaging in collective action to self-organize. So this is the list. When she's looked at, I don't know how many dozens of case studies around the world, historical ones. She has studies where she somehow got information on Spain in the 1400s and studied how they allocated water in a collective arrangement, or pastures, I forget what they were. Amazing, amazing studies. First, these are the things you want if you're going to successfully find a cooperative solution. You want a small size of the resource system. You want a small number of users of that resource. You want predictability of the system dynamics. You want a resource that is stationary and observable, clear evidence of scarcity before users invest in self-organizing. Leadership, when some users of the resource have prior skill and credibility. Shared moral and ethical standards among users, norms of reciprocity and trust. Shared common knowledge about the complex social ecological system. The importance of the resource and the ease of developing collective choice rules. Aside from number 9, importance of the resource, climate change has none of these. It doesn't meet any of these criteria to be optimistic that we could self-organize around the use of this resource. The other thing is good to point out, Eleanor Ostom's work is phenomenal, but she does not study how long it takes to get to this point. She studies cases where a community ended up with a system of rules and enforcement and monitoring, but she doesn't say whether it took 20 years or 200 years to get there. So I think that's important, especially in our current context. So that makes, I think, the situation very tough for thinking about global cooperation on climate change. I want to use one other example. I talked about the GATT and trade. This is different than environmental. I want to point out that this notion that some benefits are non-tangible, are non-market, are benefits that one can't transfer, and when the benefits of doing something that is welfare improving are non-market, are intangible, difficult to identify, we have a hard time figuring out how to make those changes, those welfare improvements that could, in some cases, result in large increases in social welfare. And to me, this is the best, the one that I would point to say this is one that economists have given up on. And that is that in the US and nations around the world, we use distortionary taxes to raise revenue. And there are welfare losses from those distortionary taxes. Estimates from 20 cents on the dollar to 30 cents on the dollar to even more than that on the dollar. So the deadweight loss of distortionary taxation is a big deal. There's been some recent literature on double dividends and recycling revenues and so forth. But the best solution is to get rid of the distortionary taxes and just use a non-distortionary tax, which we can do, which Henry George wrote about a very long time ago, and which many other economists from Adam Smith to Joe Stiglitz and many others have pointed out. It is possible to use a land tax to tax the rents of land, which will be non-distortionary because you can't move land. If you're just taxing the rents, it's a fixed asset, and there's no behavioral adjustment that's going to create a deadweight loss due to a land tax. If you add up the estimated welfare losses from using a distortionary system rather than a non-distortionary one, it's a number that is much larger than the estimated damages from climate change. It's much larger than the estimated costs of a global carbon tax, even an aggressive one at this stage. So my point is not that we should, maybe we should link these two policies. But my point is that when benefits, when things that we understand to be welfare improving are vague, intangible, difficult to measure or recognize, and difficult to recognize who will benefit. If we got rid of this, if we got rid of the distortionary taxes, who in Italy or the United States would know that they were going to benefit from eliminating the distortions in the tax system? Very few people would have a sense that, oh wow, I'm going to be better off by 10% of my income next year if we got rid of the distortionary tax. But who is going to know that they're going to take a hit, that they're going to be a loser with this change? Anybody who owns land. Anybody who owns land knows that the asset value of their land is going to go down, as soon as if you switch from a distortionary tax to a non-distortionary one. So raising property taxes, the people who oppose property taxes, they know who they are, they own land. The people who would benefit from this elimination of the biggest general inefficiency in most economies will be very hard to pass because of this reason. Okay, with that in mind, I want to turn to some estimates to some valuations that give us some sense of the social cost of carbon. Here is from Matt Cochin, a recent Matt Cochin paper with some modeling work estimated if we assume the social cost of carbon is $40, he did a breakdown of where those harms would be. And you see that most countries are below the $3 or $4 level. A couple of the ones above it are actually groups of countries, European Union, Southeast Asia. I guess India and China and the United States are the only single countries that are above $4. And those are individuals that have a $4 or a 10% share of a $40 social cost of carbon. What is their incentive to reduce carbon emissions? Is it $40 or is it $4? You would think if they're only looking at their own share of those estimated costs of carbon, it would be the $4. Looking within countries, and here I'm just trying to give some flavor for some of the numerical estimates of this, first at the international level and now national level. This is distribution of climate policy willingness to pay in the U.S., also a study by Matt Cochin and colleagues in 2013. These are some, contingent valuation surveys. And the only thing I want to point out here is that they sort of put these in categories, responses of a survey in terms of their willingness to pay for a policy instrument. This is on a per ton of CO2 a reduction, and the majority of them are below $2. Okay, so if you look at all of these different surveys, about half of the responses say they would pay $2 or less to abate carbon, to abate emissions. Okay, obstacles to domestic support for climate policy. I think I've said, and I'm going to try to speed up a little bit here, benefits are mostly in the future, they're uncertain, they're intangible, the costs are more immediate, more certain, more understood in monetary terms. The incidence is more certain and the concentration. So we get this asymmetry. The costs, people understand what the costs of climate policy are and who's going to be harmed. The benefit side is in the future and blurred. Okay, so now I turn to what I think is the most interesting part of where I'm going with this research, and that is to ask what other tools, given what I've just laid out, what other tools, mechanisms could improve the probability of action to stabilize the climate before irreversible damages become large. And I think it'd be good if a lot of people thought very hard about that question and tried to come up with things. I think there are a number. I'm sure there are some I've not thought of. I'm going to talk about 3 that I think fit this category. None of them are things that originate with me in terms of being a novel idea, but I think they're somewhat novel in the sense of connecting them with this framing of the issues that I've laid out. The first, at the international level, how can we alter the incentives among countries, those negative BJs, that produce free riding and a tragedy of the commons between nations? Second theme, domestically, within countries that are not on board for aggressively lowering carbon emissions, improve the probability of domestic policy approval, PB, by altering the level and or distribution of individuals' benefits, the B sub I's. And third, promote changes in laws, property rights and liability to leverage support for climate policy. And I've got an example under each of those themes that I'm going to talk briefly about, and then that's where I'll end up. Theme 1, Alter the incentives among countries. The strategy for that one is use tariff threats on non-participants in what's been called a climate club. Just in the last couple of years, there are a couple of really good papers on this. Bill Nordhaus's paper from last year, Climate Clubs, Overcoming Free Riding in International Climate Policy, and more recently, Boehringer, Carboni, and Rutherford had come out with a paper with quite a bit of overlap. And this is not a new idea with them, but these two papers have put some structure and some numerical analysis behind it to say, would it be feasible to threaten a small tariff if a group of countries that were in agreement to implement carbon policy, could they impose tariffs on non-participants, countries that weren't part of that climate club, and what would that do? Would they put on countervailing tariffs? Would they join the club? Would they ignore it completely? Nordhaus's analysis is I think, really excellent. Not the end of the story. I think more of this kind of work has to be done. But the idea seems to me to be straightforward. Use a threat. If carrots aren't working, if let's come together and cooperate isn't working, threatening to use that, essentially the fruits of that GATT process that I described earlier, use that, taking away the benefits of free trade as a threat to get countries to join a cooperative solution to climate. It's a really good paper. It's some numerical models where Nordhaus uses a number of these kinds of graphs to show how with groups of countries in his climate model, his DICE model, for different levels of assumptions about the social cost of carbon, what level of policy appears to be sufficient to induce other countries to join the club as opposed to stay out of the club. And he ends up with a fairly positive conclusion that for reasonably small tariffs as threats should be enough under the assumptions in his model to get most countries to decide that they should join the club. Now, there are questions about this. I think more study has to be done, but I think his conclusion that a regime with small trade penalties on non-participants, a climate club, can induce large, stable coalitions with high levels of abatement. I went through that one very quickly, but there are some articles out there, and I think they're worth reading, and I think it's, to me, an important development that has promise. Theme 2. Improve the probability of domestic policy. Strategy, use revenues from a carbon tax to finance actions where a set of A, self-identified beneficiaries are currently B, least likely to support climate policy. So you have a carbon tax, you got a bunch of money from that carbon tax. How can we dole it out in a way, or promise to dole it out in a way that will get the individuals who are least likely to approve of that policy to maybe be less, to object to it less, or maybe even, so bribing the people who are going to block your policy. Okay. Again, this is not new. This is different ways of using the revenues from a carbon tax have been talked about. Some of these would not achieve that goal, but these are all from the things that I've seen bounced around in the United States. The ones I've highlighted in red: reduce capital gains tax. Some people might find that an attraction that would lower their objections to cap and trade. Finance Social Security funding gap. Pay for health insurance for 30 million uninsured people. A colleague thought, thinking of sort of the liberal conservative spectrum in the United States, buy everyone a gun who wants a gun might be a way to capture the attention of those who might object most. That's just a joke. Okay. There hasn't been that much analysis done on that one in terms of how much, given that there's a lot of revenue, would that revenue be enough to alter the calculus among, say, the voting public in the United States or in other countries? This third one is going to take a little more explaining, but I'm going to go through it also fairly quickly because it's almost 4 o'clock. Promote modifications of law. property rights and liability to leverage support. I'm going to spend a couple minutes on this because I want to make a connection between economics and law and not just go straight to the law piece. We understand as economists that laws, institutions in general, are a public good, something that we need to organize and to create efficiency, to reduce uncertainty, to reduce externalities. Whether the laws we have promote efficiency or don't, there's an evolution and there are different perceptions about how well they do or do not promote maximizing social welfare. Richard Posner is a law professor and an economist to an extent, writing, these are Ronald Coase and Richard Posner are two names associated with the University of Chicago who have written on law and economics, that posit that common law is best explained as an effort, however inarticulate, to promote efficiency, to maximize social welfare. What I'm trying to move toward is to see how these notions of social welfare and institutions and law lead to some ideas about who should have the property right or where should the liability be for harming the climate, who should have a right to a stable climate. The third point there, government policies can be an attempt to improve on property rights only failures. That is, when you have a choice of just giving one person, the upstream or downstream person, a right to a resource, a river. Often we see a chance, a need to intervene with a government policy that doesn't just rely on individual property rights, but tries to find a middle ground through policy, through the Clean Air Act, Clean Water Act. But those can be seen as hostile to status quo interests. Just like switching the property right from one entity to another is going to be objected to by the person who has the property right. They don't want to give it up and let the person at the other end of that spectrum have it. Status quo vested interests often work against welfare improving changes in law and policy. They lock in the status quo institutions. This is a reference here to Douglas North, extremely well-known institutional economist and economic historian for his work on institutional economics, also a Nobel Prize winner. A couple more points along these lines to move it toward climate policy. Firms in some industries are concerned about losing competitiveness with climate policy. Carboni and Rivers have a paper in draft about this. There are several other papers on how, there's work in the EU about how concern about competitiveness with carbon policy. And so there are those concerns. Some industrial sectors would face large asset value losses with climate policies. Not just a loss of competitiveness, but their assets, things they own. Oil, they have rights to oil underground. They have equipment. They have factories. They have knowledge. Changes in the rules, changes in policy will reduce the value of those assets. And those could be, in many cases, huge losses. They have very strong incentives to lobby against a change in the status quo. So that's part of what we call status quo bias. These asset values represent capitalized resource rents from degradation of the atmosphere. So one of the reasons these assets are very valuable is because they've capitalized what is essentially an industry that exploits having a free place to dispose of CO2. Well, what can we do about that? We can try to make the case that there is a property right to a stable climate. The point I'm trying to make is that these objections to climate policy are very, very strong and will make it very difficult to move in a direction of a policy that is consistent with the idea that humanity has a right to a stable climate rather than this oil company having a right to continue to sell fossil fuels. If we can't negotiate that, if we can't expect lobbyists to just stop lobbying against climate policy, is there another way? Litigation. And in legal circles, this is fairly recent, but over the last 5 or 10 years, there are some concerted efforts, some really interesting efforts that I've been learning about the last couple of years, Litigation, bring lawsuits against governments and oil companies for damages from climate change. This shows you something that's going on in the Netherlands. A non-governmental organization is suing the government, the Dutch government, for not protecting the people of the Netherlands from the effects of climate change. Maybe that's a long shot. There are many of these. I'll give you an indication. Union of Concerned Scientists is adding up, these boxes indicate historically the amount of oil extracted and sold to give a sense of the contribution of different companies to the CO2 that's in the atmosphere as the basis of suing them for their portion of what has caused climate change. Here's a case: a Peruvian farmer demands climate compensation from a German company. Climate change is melting the glacier near his farm and home that's causing damage. There's a German oil company that he is suing in Germany for their contribution to climate change, which is harming his farm in Peru. Now, I thought this was crazy the first time I read about it. There are a lot of legal experts who are taking this stuff very seriously. Here is a website showing you some of the literature, you can go click on these links and see all the efforts. This is just this one is non-US climate change litigation chart. There is a lot of it going on. A lot of it has to do with human rights, access to information, and suits against corporations. There are some school children in Oregon, in my home, who several years ago filed a lawsuit against the governor of Oregon for not protecting their future from climate damages. That case is still in the courts in Oregon. It has gone through over the last several years, and it's not dead yet. And legal law experts I talk to cite public interest law and make a number of arguments here about how this might play out. They point to the lawsuits against tobacco companies in the 1960s and 70s as an example of the way something like this could evolve. In a country, is environment covered under human rights? Is climate covered under environment? If so, then oil companies or governments could be liable for violating human rights. So a human rights angle or leverage to sue oil companies on behalf of the public could lead a Supreme Court in a country to rule in favor of the public and against an oil company. And even if that oil company has no standing in that country, I am led to believe that there's a domino. Legal cases in one country can be used in the court in another country to add weight to an argument being made in that second or third country or fourth country. The process will raise public awareness. Information will be obtained through discovery. That's already happening. Evidence that companies have suppressed information or disseminated misinformation could be explosive and raise liability issues to a new level. ExxonMobil, this was found in ExxonMobil in New York. Public opinion could shift. Companies might eventually seek protection from liability in exchange for supporting climate policy. So the idea here is, if you could push this along to the point where you have exposed companies who have tried to suppress information that they knew that their product was changing the climate 20, 30 years ago, they might find themselves worried about their own liability and change their position and go with their lobbyists to Congress and say, okay, let's make a deal. If you will protect us from future liability, we will support a carbon tax or cap and trade. They will sort of change their lobbying position. And that's sort of the kind of scenario that these legal remedies are pursuing. So that's where I'm going to stop. Just to sum up, because I don't want to give the impression that I'm saying lots of things economists and other people are doing now is not useful. What I'm saying is something in addition I think is needed. Past and ongoing work by economists, governments, individuals on climate change issues are necessary but not sufficient to achieve timely success. The no time for wishful thinking view is not new but needs to be taken more seriously by more people, I believe. Looking beyond standard approaches, I'm suggesting there may be mechanisms that complement and leverage ongoing efforts. And my own work is to I think, make this case firmly in a written form. And I think there are some additional places in what I've described to you where I want to focus some attention going forward with maybe some more specific kinds of research. So I'm done.